Hello and welcome to this NCFE provider session, CPD Maths Unlocking Underpinning Skills. My name is Charmaine Phelps and I'm a provider development officer here at NCFE, and it's my role to support you with your planning, delivery and preparation for functional skills assessments. The objective of the session is to explore strategies to teach functional skills maths underpinning skills. We'll look at underpinning skills questions in assessments. We'll look at some common learner challenges, teaching strategies. We'll look at the theory of retention and retrieval, and then some retention and retrieval strategies, and then end with a short summary. So starting off with looking at underpinning skills questions in assessments. Here we have the structure of entry-level maths assessments in the new style. Remember, our assessments changed on October the 17th, 2025. And you have the underpinning skills marks shown here for the different entry levels and also the problem-solving marks. And what you will notice is that the total marks and the duration of the assessments has not changed since before October 2025. But what has certainly changed is that those underpinning skills activities are separated out from the problem-solving activities. And here we have the marks and timings for level 1 and 2 assessments. And just to keep you on your toes, I've coloured in or hidden the underpinning skills marks. You can see how many problem solving marks there are for section A and section B. That's the non-calculator section and the calculator section at level 1 and level 2. It's the same number of marks for level 1 and level 2 and the same duration. You can test yourself and think how many underpinning skills marks are there in the non-calculator question section, and how many underpinning skills marks are in the calculator section. I'll reveal. You've got five marks available for underpinning skills in the non-calculator section and 10 available in the calculator section. So it is quite straightforward, as the total number of marks remains at 60. Here we have some examples of underpinning skills questions at level 1 in the new style. So our first one is simply write these numbers in order of size, starting with the smallest. There's no context given, no context needed. We're just assessing underpinning skills, so we've just got the question with no context. Similarly, 1b, calculate 4 times 9 squared. Quite straightforward. 1c, work out the range of these numbers. Again, no context in any of these questions, and you can see in the mark scheme it's clearly labelled that these are UPS underpinning skills questions, and the mark scheme will tell you what the marks are awarded for. At level 2, we have some examples here from the calculator section. So 3a, we're looking at underpinning skills. We don't need a context. It's simply what's the name of the shape. Tick the correct answer. For 3b, again, no real context needed. Put these numbers in order starting from the lowest. So no context there. However, for 3c, which is assessing H26, work out the probability of combined events, including the use of diagrams and tables, including two-way tables, some context is needed in order to make sense of the diagram that illustrates the combined probability, and therefore minimal context is given. And you will find that, so underpinning skills questions can assess any of the subject content statements, and you yourself will find it very difficult if you try to write a question for every single, an underpinning skills question for every single one of the subject content statements. You will find that for some of them, particularly the handling data and the measure content, it's actually very difficult to do that without putting a little bit of context in, just to help to make the question make sense. So again, we've got this question, which is assessing, well, it actually is assessing number, calculating original value. So that's N6, original value after a percentage change. But if we did not have a context when we're looking at original value, it would actually be quite difficult to make sense of the question. So we've got a house valued at 261,600 in 2024. This was 9% higher than its value in 2023. Work out the value of the house in 2023. So just because there is a context doesn't mean it's not assessing underpinning skills. That is what is being assessed here. It's just that context helps your learners to make sense of that question and to see that it is an original value after a percentage change question. We're going to have to think about what our learners typically find challenging. And if you're watching this as a recording, it's always helpful to, you can pause this recording whenever you like and take part in the activities that we set in the live session. So in the live session, we used a Padlet, and on the Padlet, our groups on the top row, they listed a maximum of 5 challenging topics, and then below that they said why they found it, either why their learners found it challenging, these particular topics, or why they found them challenging to teach. And I'll share with you one of the group's results. So one of the groups in the section had said that some of the challenging concepts or topics are fractions, place value, percentages, scale factors, and rounding. And the reason behind this, when it comes to fractions, sometimes their learners had very little prior knowledge. With place value, sometimes it might just be issues with language and ESOL. With percentages, there's so many different ways that percentage questions are worded, and particularly actually if you have learners who have English as an additional language, and I can see that word of is jumping out at me there, because with percentages we often have of, a percentage of something or a percentage off something, and just that extra little f makes all the difference to what the question is asking. Scale factors, this can be quite difficult, how to use them in shapes. And when it comes to rounding, what can be the challenge is the language used around that and the assumptions. If you're asking me to round, do you want me to round to 1 decimal place, to 2 decimal places, to a whole number? So that's what one of the groups in the live session came up with. Now, when it comes to teaching strategies, the qualification specification is going to tell us what we need to teach. Okay, those subject content statements, they list all of the underpinning skills. And we've had a little bit of time to think about what our learners typically struggle with. Now what we need to do is turn to how we're going to teach the full content. So all of those underpinning skills, in particular the challenging topics, because it is only through teaching those underpinning skills that it will allow our learners to be able to employ these in real life, but also be able to access those what makes up 75% of the assessment, the problem-solving questions in maths functional skills assessments. We need our underpinning skills first. You can access the qualification specification from the Support Materials tab of the qualification page, and you can access the free scheme of work from the Teaching Materials tab. So if you want to access this, all you will do is go to the Teaching Materials tab, go to where you can see the resources. So for example here, level 1, and it's the same for level 2 for maths, and in fact for entry levels as well. Hit the find out more where it's got the chargeable resources, and from that find out more it opens up into this on the right hand side, and from there you can actually click to download the sample resources. And for maths functional skills, our free scheme of work is actually accessible through that link. So if you'd like to access our free scheme of work, you can do so by going to the teaching materials and clicking on the Find Out More, and then clicking to download the sample resources, and no login is required in order to do that. And here's an example of a section of our scheme of work. The scheme of work adopts the mastery approach to delivery. It aims for all learners to achieve a deep understanding of mathematical concepts rather than just memorization. Now, you can see that it does refer to PowerPoints and the worksheets, which are in the chargeable resources. It's not mandatory for you to use either our free scheme of work or the chargeable resources. But looking at the scheme of work can help you to come up with some ideas, either in the way that you decide to plan the full content over the time period of your delivery, but also you can see a range of teaching methods that are used. So for here, we're looking at teaching N8 basic fractions and N9 finding fractions of whole number quantities or measurements, and again it is level 1, N15 estimating answers to calculations using fractions and decimals. And we've got the various different learning outcomes, learning activities, and also how you're assessing throughout the session, and different strategies that are used. You can see here, like teacher questions, relating the topic to real life, pair work, discussion, worksheets, etc. So by all means, take a look at those schemes of work to get some ideas for how you would like to structure your delivery. This diagram is amended from the National Centre for Excellence in the Teaching of Mathematics website, and it gives an overview of the 5 big ideas, the core themes behind the mastery approach. So remember, I said that the scheme of work is based on the mastery approach, which I recommend that you look into if you've not already heard of the mastery approach to teaching maths. So we start off with coherence. Your teaching is designed to enable a coherent learning progression through the whole curriculum, giving access for all learners to develop a deep and connected understanding of maths that they can apply and communicate in a range of contexts. And how are you going to do that? Well, let's look at our 4 quadrants around this circle. So representation and structure. Carefully selecting representations of maths can help to expose the mathematical structure. The intention is to support learners in seeing the maths rather than just using representation as a tool to do the maths. Representations can become mental images that learners can use to think about and talk about maths, which can support them to achieve a deeper understanding of the structures and make connections. Then we have mathematical thinking, which is central to how learners learn maths, and includes looking for patterns and relationships, making connections, reasoning, generalizing, conjecturing. Learners should actively engage in mathematical thinking in all lessons, discussing and communicating their ideas using precise mathematical language. Then we have fluency. Efficient, accurate recall of key number facts and procedures is essential for fluency, and if your learners have developed that fluency, it frees their minds to think deeply about the concepts and problems they're faced with. But fluency, it does demand more than this. It does require that learners have the flexibility to move between different contexts and representations of maths, to recognise relationships and make connections, to be able to explain ideas and choose appropriate methods and strategies to solve problems. And I'm sure you're aware that when it comes to looking at our functional skills, problem-solving questions, being able to choose the correct strategy to solve a problem is sometimes far more difficult than even just using that strategy and coming to the answer. Just knowing what to choose is what can be very difficult. And then finally, we have variation, bringing everything together. And the purpose of variation is to draw attention to a key feature of a mathematical concept or structure through varying some elements while keeping others constant. And this can help you to focus thinking and discussion on the key feature in question. And again, we set this as an activity. So after we'd completed the first 2 rows, looking at challenging topics and why they're challenging, and the next thing, together in the groups, our groups noted down how they could or how they do already overcome the challenges. So they noted those in the 3rd row, and I'll go back again and I'll show you what one of the groups had written. So it's the same group as before, and for fractions they suggested using visual examples, using non-examples. So showing them, like if they're talking about a third, they'll show them an example where, for example, the attendee explained that if there was a rectangle, like usually if you want to show a third, then you would show a rectangle split into 3 equal pieces, shade one of those pieces, and there we've got a third. However, if you show non-examples, then that means that instead of it being 3 equal boxes in that rectangle, they'd be different sizes, and yes, one of them will be shaded, and you will ask, so is that a third? And hopefully your learners will say no, and then it's about asking them to explain, and it is in explaining why it's not a third that your learners are showing that they actually understand the concept of a third. Place values, one of our attendees was telling us a great way, like a game of getting your learners up on their feet, and having them as like each, in a row, your learners are standing there in front of you, and each of them has, you've got somebody who represents the thousands, the hundreds, the tens, the units, the decimal point, and perhaps tenths and hundredths. And as you are multiplying a number by 10, for example, you would then get all of the learners to move one place over to the right, if they're right if they're facing you, in order to multiply by 10, and similarly go the other way if they're dividing by 10, or 2 spaces if it's by 100, for example. So some nice ways of getting it up on their feet. Percentages, making connections to other topics. Scale factors, the attendees were talking about drawing the examples of like here's the scale version, and here's the actual size of the object, much larger. Can be really helpful to understand what that scale factor means. And when it comes to rounding, our attendees were telling me about the need to use very precise and deliberate language when you are talking about rounding and estimation. And again, if you've taken the time to pause the recording and think of your own challenging topics and why they're challenging, hopefully this has given you some ideas. Nearly all of the groups actually suggested using like physical objects or making things very practical in order to get those particular challenging topics across. Now, as we've mentioned, representations and variation are really helpful for learners to understand the concept you're teaching. However, there is a time and a place for activity sheets where it's just lots of repeated multiplications, for example. We've got subtractions here. So these particular resources are free resources that I've found on the internet, and I've placed them on a Padlet. You should be able to access the Padlet link from just below the YouTube video. And they're really useful for repeated practice so that processes become automated. Your learners are just, they're really used to doing this. And it is this automation of processes that leave space in your working memory for more complex problems, or needing to use these underpinning skills in a problem-solving question or a real-life problem that requires these underpinning skills. Now, it's all well and good teaching the content, but our learners need to remember it, and they also need to be able to retrieve the correct strategies to use to solve problems in their assessments, their lives, their work, and other studies. I sometimes think about my brain being like inside my brain, it's like a library book, and not a library, it's like a library. So I've got lots of shelves in there and lots of books, and I'm hoping that I've got all the right information stored in those little books in my brain. But when it comes to, so that's my retention, my storage of information, but can I retrieve that information? Do I know where I place that book in my brain in order to get that piece of information out and use it? So that's what we're talking about when we're talking about retention and retrieval. And before we explore retrieval practice in more detail, we're going to look at how we retain information in our minds. Now, this diagram, I've taken it from Craig Barton's training on the 4 ingredients of retrieval, which is linked on this slide. So we've got retrieval strength on the x-axis, so that's me being able to know where the little books are in my mind, and storage strength on the y-axis, have I actually put it in the books in my brain. We want our learners to have their maths knowledge stored strongly into their memory, and we also want them to be able to retrieve that knowledge easily. So our aim is for maths knowledge to be in the top right quadrant by the end of their course. However, all too often that is not the case. So we're going to think about how our own memories work now. And we did this as a group activity. So if we consider point A as something that, I don't know, perhaps I told you 5 or 10 minutes ago, it might have a high retrieval strength because I only mentioned it a short time ago. However, if you try to remember it in a week, it's unlikely you'll be able to remember it. The storage strength is weak because you perhaps you may not have any reason to store it. I actually used the example in the live session at the start of the session. I told them when my birthday was this year, and then at this point I asked if anybody could remember it. A few people did remember it, so that's kind of my example for something that I could have told you just now, that is actually pretty useless information for you guys. Very important for me. Point B, that's again, that's where we want the maths knowledge to be. If you think about something that you are able to retrieve just like that, you know exactly, like your childhood home phone number. And why can I remember my childhood home phone number? I can even actually remember the telephone number of my best friend, because I used it lots and lots of times. I stored it very safely away in my brain. It's got a high storage strength and also a high retrieval strength. Point C is one of those things where it's in there somewhere, somewhere in my brain there is a book containing, I know I have a book containing this really, really important piece of information that I need to know right now, but I just cannot for the life of me think of it. And then finally we've got point D, those kind of facts that have a very low retrieval and storage strength, like a hotel room number from 5 years ago. During that holiday you'll have remembered that room number every day for a week, but now no idea what it was. Why? Because there's no need to remember it. And you may find certain maths knowledge with your learners that they've mastered it during the week of your delivery, but they've completely forgotten it by the time it comes to an exam. And just to give ourselves a bit of an example of how our own minds work, this is where the attendees, they put song lyrics. There's loads of song lyrics up with a high retrieval and a high storage, which is why, and it's good to see this here because you can kind of think about if this is how pretty much most of us, this is how our brains work. It can help us think about how we're going to help our learners to store information and be able to retrieve it. So using song lyrics is a great way of teaching a teaching tool, like little mnemonics and things, like the hey diddle diddle, the mean, the median's the middle, that kind of thing. So you've got some ideas. You can think for yourself as well. Past students' names when they walk up to you. Retrieval strength is kind of middling there. Storage strength, no, not stored at all. You know their face, you know exactly who they are, but what's their name? No idea. Not stored. We've got this diagram. You may be familiar with this. It's the forgetting curve. It was first developed around 1885 in a very limited study with himself as the only subject by Herming Ebbinghaus. And again, I've taken the diagram from the Craig Barton course that I mentioned previously. So the way this forgetting curve, we can see we've got over time. We've got our memory retention on the y-axis. So when we first learn something, right, we've got it, right? It's not had any time to slip out of our memory. But this first curve, you can see it's very steep. Well, we first learn something, and very, very steeply we just forget it. It's falling, slipping out of our memory. But if we review that, after not too long a time, then again it comes back into our memory, and this time the curve is less steep. It takes a longer time for whatever it was that we learned to slip out. And then again, if we review that the information again, we might be able to let a little bit more time elapse. But the learning curve is the forgetting curve is less steep still, and even more so if we go and review that content again. Now, given the limitations of the study, it's very easy to question the exact shape of the curves and also the exact period of time before forgetting occurs. However, you'll know from your own experience of your own memory and that of your learners that the initial curve and the lessening gradient of subsequent curves makes sense. That memory is reduced over time, and that memory can be improved by reviewing the learning again at a later date, which in theory reduces the gradient of the forgetting curve so that it takes longer to forget new learning after repeated spaced reviews of the learning. Now, factors that influence the forgetting curve are the difficulty of the new learning, the relevance, how it is represented, and other physiological factors such as stress and sleep. And we come to testing for learning. Tests have metacognitive benefits in terms of identifying whether information has or hasn't been understood and or learned. So not just as a formative assessment tool. You may yourself have thought about how if you were going to learn a speech, for example, for a wedding, how would you do it? You would perhaps write down your speech and then test yourself. Can you remember certain parts of it? The tests themselves are low stakes. They're not assessed, but they help us to remember what we want to learn. And this quote here from the study that's referenced later on in the slides, unfortunately, the effectiveness of tests as learning events remains largely underappreciated, in part because testing is typically viewed as a vehicle of assessment, not a vehicle of learning. But that active recall, the pressure that we put on ourselves, providing it is pressure we put on ourselves, it's fairly low stakes to remember. That in itself is a way of learning because it allows for the generation effect to occur. We're generating an answer. This refers to the long-term benefit of generating an answer, solution or procedure versus being presented with that answer, solution or procedure. Basically, any time that a learner has to look up an answer or somebody tells them or shows them something that they could have, drawing on current cues or past knowledge generated for themselves, then they're robbed of a powerful learning opportunity. So retrieval, in effect, is a powerful memory modifier. Giving hints or clues to find a correct answer may be useful in the short term, but it denies a learner from the opportunity to retrieve the answer for themselves. If testing is regular and has low stakes, learners will suffer less from the motivational impact of a low score and learn from the questions that they didn't get right at that particular time. Performance over time may show learning, but for the most part, performance, for example, getting an answer right at the end of a lesson, doesn't necessarily show learning. So conditions that lead to high performance, such as giving clues, getting learners to work together, etc., may actually hinder long-term learning. Another benefit is that tests can improve the effectiveness of subsequent study opportunities, even under conditions that mean learners will be incorrect on the test. If you think about it, you often remember why you got something wrong more easily than remembering things that were not a struggle or you could do at the time that you were asked. Again, the basic message is that we need to spend less time restudying and more time testing ourselves. And I actually said a similar thing in my recent revision CPD session. Following on from the forgetting curve, results indicate that compression of learning into a too short period is likely to produce misleadingly high levels of immediate mastery that won't survive the passage of substantial periods of time. So reviewing learning after ever increasing gaps can help with retention and retrieval. And similarly, we've got interleaving versus blocked delivery. So we have a blocked delivery pattern shown on the slide. We cover all of topic A, number, for example, then B, measure, and then finally focus on C, handling data. If we then take a test at the end, we may do very well on the questions covering handling data, but we might struggle with some of those topics in number that we haven't necessarily gone back to. Interleaving delivery supports retention and may look like this. And actually, if you take a look at our current scheme of work, that is very similar to the pattern that we see in our current scheme of work. The interleaving approach shows how students switch between topics whilst revisiting in order to improve and deepen their learning. Mixing up the order of learning within a content area benefits not only the long-term memory of what's being studied, but it also helps learners to make connections and leads to benefits in the transfer of learned skills. And we did an activity in our session to think about how we embed retrieval practice into delivery. And this is what our attendees placed onto the Padlet. So using retrieval practice, embedding the past topic into a new topic, linking new learning to prior knowledge, that's kind of similar. A lot of people were saying about starter tasks that revisit recent or not so recent material, looking at mentoring with students, recapping, integrated practical tasks, linking learning to practical activities and referring back to these. And on this slide, we have the references that I've used and referred to. So if you would like a copy of the slides, please do let me know. You can contact me. My email is at the end. But now we've looked at some theory, let's look at some retention and retrieval strategies. We've used this before, actually, retrieval tables. This is a new retrieval table that I've created specifically for this session. I can send it to you if you would like. So we've got the way a retrieval table works is you get a pair of dice. Ideally, if you've got face-to-face learners, then you will pair them up and give them a couple of dice. The first roll gives the column and then the second roll gives the row. We are reinforcing our knowledge of coordinates here by going across and then down. So for example, here we've got 3, 4. So the question is, it takes 4 people 20 hours to build a wall. How long would it take 8 people to build a wall at the same rate? So the pair have got this question to answer, and hopefully they will give a correct answer. So it will take them, if it's double the amount of people, it's going to take them half the amount of time, so 10 hours, and then the the pair can then roll on. So you can give a table like this as a starter activity and just see how many questions your learners can go through before their time is up. But all of the questions are looking at content that you have previously covered. And here we have Venn diagrams. Craig Barton has an excellent website, Maths Venns, where you can find lots of examples for Venn diagrams, and everything on there, all the resources are completely free, which is great. So for this particular Venn diagram, we need to state the dimensions of a rectangle that's going to fit into each region. So anything in the purple circle, the area needs to be less than 30 centimetres squared. In the green circle, the perimeter needs to be more than 30 centimetres. And anything in the black circle, the height needs to be 3 centimetres. So you can pause the recording and try to complete the Venn diagram. Think of as many rectangles as you can. And this is a great thing when if you set this as a group task, then everybody can take part at their own level. We'll take a look at some answers on the next slide. And on this slide, we have some potential rectangles that fit in the certain regions. We can't fit anything into the central region because it's not possible to unfortunately have an area of less than 30 with a perimeter of more than 30 and a height of 3. You can look at that. So you've got the 3 times 9 will have, all of these, have got the height of 3 centimeters. This one, 3 times 11, the perimeter is greater than 30, but the area is not less than 30, whereas the 3 times 9 gives us an area of less than 30, but the perimeter is less than 32, so we can't pop it into this central one. And obviously, as I mentioned, if you're using this as a group activity, we've put just one possible dimension in each of the regions. But once we've got 4 times 5, I can put anything. The area is less than 30. Let's think 2 times 4. 2 times 4. That will have an area of less than 30 centimeters, and the perimeter will be 8, 9, 10, 11, 12. The perimeter is less than 30, so I can put that one in the purple circle as well. So there's lots and lots of ideas, and sometimes it's, if you've got some, once you've got one idea into a circle, it can help those learners who perhaps didn't want to go first or weren't quite so sure, particularly if you are encouraging the group to talk about why they are putting certain, in this case, dimensions of rectangles, why they're placing them in certain regions. Flashback 5 are daily mental maths activities that are questions linked to previous learning. How you deliver your own Flashback 5, it's used in a lot of centres, will depend on your setup, but as an example, there's a word wall activity here. You can scan the QR code with your phone, or you can go to the website address that's shown there and see the Flashback 5. It's basically 5 questions on a particular topic. Just a nice, quite straightforward, quick and easy starter. Self-marking sheets are a useful free resource that allow you to set worksheets that mark themselves. You can use the pre-populated sheets that are on the site, or use the instructions to create your own. And as an example, this particular one that I've looked at, this is a pre-populated one on equivalent fractions, and the way that they work is, and you can, they're quite good set for homework. So again, you can build retrieval practice either into a starter activity, as the ones that we've just looked at work very well as a starter activity. Alternatively, looking at some homeworks. So for this, for example, if you set these for your learners and then they enter in the correct answers, you can see it gives them a score for each one and it marks it as green, so they know they've got the correct answer. These particular sheets, they're they're quite straightforward. We're doing the same thing over again, which is quite good for building up that automation of processes because like we're just doubling to see and get the equivalent fraction for the first two. But as we go through the sheet, we've then got some slightly harder ones. But again, it tells us what we need to do. We need to times 4 times 3, for these particular rows. But the final one is mixed. So we're being tested a little bit further. We're not just being given what we need to do to find that equivalent fraction. Diagnostic questions, I've mentioned this before. It's a great website. It's fantastic for setting frequent low stakes tests and can also be used for homework. Signing up and managing a class of learners is free, and you can find ready-made questions to pull together into a quiz or find complete quizzes that test certain topics. Each question has 4 possible options with 1 correct answer and 3 answers that learners could easily put if they had a common misconception. As an example, this is a level 1 question, so they need to round 3,782 to the nearest 100, and you've got these possible answers, and when your learners put their answers, what they also need to do is write an explanation. So in this case, we're going to give an answer of, we're rounding it to the nearest 100, we're going to round up to 3,800, and we've got our explanation here. 8 is more than 5, so it gets rounded to 3,800. And this example is one that we showed in the session, so this one is on probability. And not only can you set these as, for example, a homework to be done by your computers by your learners, on their devices, but you can actually create PDFs and print them off. So this is like a printed off version on a PDF, where again it's exactly the same concept, where you've got a question and then there's 4 multiple choice answers with an explanation. And you can also gain insights about those questions. So for the 5 questions that we've just seen on the previous slide, we can see which one, question 2, we can see has got a greater proportion of green, so more learners got that correct, whereas question 3 has a greater proportion of red, so more learners have got that incorrect. And it's possible that the reason behind that is because it involves a pack of playing cards, and not all learners are familiar with playing cards, so that is possibly why that particular question has got the most wrong, possibly, but there may be other reasons. And down below you've got an explanation for why you've got the correct answer and the incorrect answers. On my Maths Padlet, which is within the NCFE Maths and English Padlet, so from this link you can, that I've got here on the slide, you can click onto the NCFE Maths Padlet, and I've placed links to the resources used in this session, as well as some others. It is important to note that any third-party external links that I've shared are not NCFE endorsed. They're simply resources that we've used in our own teaching or have been recommended to us by other providers. We'll end with a summary, but first, you may like to think about what is your key takeaway from this session. What's the one thing that, if you've listened all this way through, what are you going to take away with you? And I'll show you what our attendees at the live session said. So retrieval is that need to do retrieval practice. If you're not constantly, but as well as teaching the content, if you are setting activities that enable your learners to practice retrieval, then it is going to help your learners to be able to retrieve, but hopefully also be able to store what you are teaching them into their long-term memory. In summary, underpinning skills are assessed at 25% in the assessments and as much as possible do not contain a context. It's important to master the underpinning skills to be able to approach the problem-solving questions. Using the free NCFE scheme of work can ensure that all content is covered and a range of teaching strategies are used. Repeated practice of underpinning skills helps with automation, and variation in practice supports understanding. Retrieval practice built into delivery supports retention. If you have any questions related to this session, please do feel free to get in touch. A great way to get in touch is to complete our feedback form. This feedback form is for this recorded event specifically. It's a different feedback form that we use in our live events, but if you have watched this recording, then you can complete our feedback form, which is great. Tell us what you think about this recording, but also it's a completely anonymous survey unless at the end it says if you've got any questions, and at that point you can actually there's an option to choose, yes, please, can you contact me? And then you can give your contact details. So if you do have any questions on this session, the best way of asking those questions is to complete this feedback form and leave your email address, and I'll be able to get in touch. Otherwise, the feedback form is completely anonymous. You'll find all our upcoming CPD events from our functional skills events page on the website, which is linked here. Thank you so much for your time in listening, watching this recording. We've got key contacts on this final slide for you. So if you do have any further questions, please don't hesitate to get in touch. Thank you.